Hello, this is Mrs. Huntley. We are still solving systems of equations. We've finished the graphing part and we're going to be looking at substitution today. Now you should have picked up a new packet in class today. I will be uploading it onto the Google Classroom so that if you don't have it for some reason, you can take a look and find it on the Google Classroom. We are stepping out of the Eureka materials just for the next week or so, looking at substitution and elimination using some different resources. Okay, so your essential question, what is the advantage of substitution method over graphing a system of equations? And you should be on page 1 of the supplemental materials. Now it says the 1 in the bottom right hand corner, and I know the numbering is kind of goofy, but your page should match my page and have the same EQ and the same graphing. Now the warm-up we did in class today, and I was a little bit surprised at how many people are still struggling with graphing equations. So we're going to quickly review for those of you that are struggling with this for whatever reason, and we're just going to go over the y equals mx plus b. Now b is your y-intercept. You can also say it's the beginning of where you're going to be putting a point on the graph. P-E-G-I-N-I-N-G. That's ugly. M is your slope. You can think of it, M, how am I going to move from my beginning? And that's your rise over your run. So when something's in slope-intercept form, like this part of the equation is, it should be pretty easy to graph. Start with the number that's at the B. Where does that cross your y-axis? So you should put a point here at 1. Your slope, there's no number with the x, but there is an x there, so you know that there's a 1 out in front of it. So from your beginning, you go up 1, right 1. And then you draw a line through those points. I want a red line here. Next, we're going to do the other equation. But wait, the other equation is not in slope-intercept form yet. So we've got two. Oh, I'm going to change colors. I've got 2x plus y equals 10. If I want my y by itself, I'm going to subtract 2x from both sides of the equation. And now presto changeo, I am in slope-intercept form. Go ahead and graph this line. Pause the video, graph this line, and then check to make sure that you've got this down. Okay, start with your B, your beginning, and then count from your beginning how are you going to move. Okay, your line should look like mine in green. Now wait, we're not done yet. We've just graphed the two equations. What we need to do is identify the point where they're crossing. That's the solution. So it's at, here's 0, 0, so x is 1, 2, 3. X is 3, and y is 1, 2, 3, 4. So I'm saying the solution to this system is 3, 4. I could, at this point, go in and substitute in my values for x and y into both equations and make sure that they are true. I'm not going to take the time to do that because this is review right now. So go ahead and pause the video and go ahead and graph the second system here. Okay, your graph for the second system should look like mine. Y equals 4, that is, there's no slope there. So remember, check Mr. Slopeman if you have to. Y equals 4 is going to be a horizontal line at the y-axis where y is equal to 4. The point where the two lines are crossing is here at negative 1, 2. So negative 2 and 1, 2, 3, 4. Negative 2, 4. This is review. This is what we've been doing for a while. If you're still struggling with how to graph a line or how to figure out a solution to a system using graphing, you need to rewatch some of those older videos. Let's move on to the new material, solving a system using substitution. So we're going to look at the same equations that we just graphed. And what we're going to do is figure out how to is learning new alternative method for solving the system. So when you have one or both of the equations that say y equals or even x equals, you know that that variable is equaling whatever it says that it's equal to. So what I'm going to suggest is that we take parentheses and we put parentheses around whatever y equals, and we take that whole thing and substitute it in for the y in the other equation. So I'm going to rewrite it as 2x plus x plus 1 equals 10. Now you might have had your parentheses around it, and that's fine. We don't really need the parentheses in this particular problem because there's no number in front of the y in the second equation. So I'm going to take the parentheses away there. Y plus 1 equals. Okay. So now I have a equation in one variable. We started off Module 4 learning how to solve equations in one variable. So we've got 2x plus x. We need to combine those like terms. So I'll have 3x plus 1 equals 10. I need to isolate my variable term, so I'm going to subtract 1 from both sides. So I have 3x equals 9. Divide by 3, and x equals 3. So I have half my answer using substitution. Now I'm going to take that 3 and substitute it in for x in this equation. So I'm going to have y equals 3 plus 1. Oh, now that couldn't be easier, could it? Y equals 4. So my other half is 4. Now I can check my work by plugging in my values or substituting in my values for x and y into the second equation. Whichever equation I did not use already, I can use it now to check my work. So does 2 times 3 plus 4 equal 10? Let's see, 2 times 3 is 6, plus 4, 10 equals 10. So it works. I can also go back and check. I already solved this using graphing. So go back and check, and hey, my answer when I was graphing it was also x is equal to 3, y is equal to 4. So let's come back to the other example from our warm-up. And I have both equations saying y equals something. That's okay. I'm just going to take one or the other and substitute it in the other equation. It can go either way. I can have negative 1/2 x plus 3 equals 4, or 4 equals negative 1/2 x plus 3. Now this is, I'm again looking at each side of my equal sign. I've got an equation in one variable, and I know how to solve these. The left side of the equation and the right side of the equation are already completely simplified, so I just need to go ahead and try to isolate my variable term. So I'm going to subtract 3, and I've got 1 is equal to negative 1/2 x. Now that's negative 1/2 times x, so what I want to do right now is kind of divide both sides by a negative 1/2. Hopefully you remember that when you're dividing by a fraction, you're actually multiplying by the reciprocal. So I'm going to multiply by a negative 2. And x is going to equal negative 2. So I have half of my answer here. But wait, I don't even have to do any math to figure out what y equals, because it's telling me right here that y equals 4. Now I can take those answers and check them in this top equation. So does 4 equal negative 1/2 of negative 2 plus 3? Now a negative times a negative is a positive. Half of 2 is 1. 1 plus 3 is 4, and 4 equals 4. So it's a good answer. I can also check. When I graphed it, I said negative 2, 4. When I solved using substitution, I say negative 2, 4. So I know that's a good answer. Hopefully this is making sense to you. If you were watching, during class today and you were like, okay, I don't get it, or if you were absent today for any reason, that's why I'm going over the entire lesson instead of just going over the homework. So let's look at some more examples together. This first one, x equals negative 1/2 x plus 3. I'm sorry, I said that backward. Y equals negative 1/2 x plus 3, and y equals 1/2 x plus 6. Again, it does not matter whether I take this top equation and substitute it in down here, or if I take this bottom equation, or expression, excuse me, and substitute it in up there. It's been a long day, guys. I'm going to be saying things wrong, and I apologize for that right now. So I'm going to rewrite the equation. 1/2 x plus 6 is equal to negative 1/2 x plus 3. Look at each side of the equation individually. On the left side, I do not have any parentheses to distribute. I don't have any like terms. Same thing on the right side, so I can start. I've got variables on both sides of the equation though, so I need to move them all to one side or the other. So I'm going to add a 1/2 x to both sides. If I have a 1/2 and somebody gives me another 1/2, I have a whole, so I have a whole x plus 6 equals 3. Subtract 6, subtract 6, and x equals negative 3. Now I can take that negative 3, I have half of my answer, x equals negative 3. I can take that answer and substitute it into either equation. It totally does not matter. I'm going to pick the top one just because it's on top. I'm going to say y equals negative 1/2 times negative 3 plus 3. I know a negative times a negative is a positive. A 1/2 of 3 is 1.5. So positive 1.5 plus 3. So y is going to equal positive 4.5. I have the other 1/2. Now I can check my work by plugging into the other equation. So I use the top one to solve for y. I can use the bottom one to check my work. So 4.5, is that equal to 1/2 of negative 3 plus 6? Okay, 4.5. 1/2 of negative 3, as you see, a positive times a negative is going to be a negative, so it's going to be negative 1.5. If you need to, grab a calculator. Negative 1.5 plus 6 is 4.5, so that's a good answer. Okay, the next equation, do the one to the right here. I've got y equals negative 3x plus 1, and then I have 3x minus y equals 7. So being that the top equation has my variable isolated already on the left side, I'm just going to take that value and substitute it in for the y right there. So I'll have 3x minus the quantity 3x minus 1 equals 7. Now remember back to when we were solving equations in one variable. When I have a negative sign out in front of the parentheses, I have to distribute that negative sign to everything inside the parentheses. So I'll have 3x minus 3x plus 1 equals 7. 3x minus 3x is going to be 0, and I'm going to be left with 1 equals 7. Oops. But 1 doesn't equal 7. So this is going to have no solution. I don't have to do any more work. That means these two lines are parallel lines. They share the same slope, but they do not share the same y-intercept. My work on that one is done. The next one on the bottom left here. I have x equals y plus 3, or I'm sorry, the top one is 2x plus 2y equals 38. And the bottom one is x equals y plus 3. And you're probably thinking, but it's not in slope-intercept form. It doesn't matter. I know what x equals. One of the variables is isolated, so I can take that quantity and substitute it in for x in the top equation. So I'll have 2 times the quantity, y plus 3, plus 2y equals 38. Evaluate the left side of the equal sign. I'm going to have to distribute, whoops, there we go, distribute the 2 over everything inside the parentheses. So I'll have 2y plus 6 plus 2y equals 38. Combine some like terms. 2y plus 2y is 4y plus 6 equals 38. Subtract 6, and 4y equals 32. Divide both sides by 4, and y is going to equal 8. I almost said 32. So I have half of my answer. Now be careful when you're writing your ordered pair. If you solved your y first, make sure you put it over here on the right. And then take that value and substitute it back in. I'm going to substitute, you could choose either equation to substitute it back in to solve for x, but this bottom equation already has x isolated, so it's going to be easy peasy to solve for x here. So x equals 8 plus 3. Couldn't be easier. 8 plus 3 is 11, so I know my y is going to be 11. Now again, I can check it using the other equation. So 2 times 11 plus 2 times 8, does that equal 38? So does 22 plus 16 equal 38? Check on your calculator. 38 does equal 38. It's a good answer. The last one that I'm going to do completely with you, and then I'm just going to kind of nudge you along on your homework problems. I've got y equals 8 minus x, and I have 7 equals 2 minus y. So being that I've got my y isolated here, I'm going to take that whole quantity and substitute it in for that y there. I do want to keep my parentheses here because that's a negative sign there, and I'm going to have to make sure that I distribute that negative just like I did on that problem that's up above. So what I'd like you to do is go ahead and pause the video and see if you can get this problem set up without me. Okay, you should have set it up as 7 equals 2 minus the quantity 8 minus x. So now remember, it's like a negative 1 out in front that needs to be distributed here. So go ahead and see if you can do the next step and check your work. So x equals 13. I'm going to take that and plug it into this top equation because the top equation also already has your y isolated. So y equals 8 minus 13. If you don't do integers well, grab your calculator. 8 minus 13, y equals negative 5. So your y is going to be negative 5 here. Now you can check it. Does 7 equal 2 minus negative 5? When you're subtracting a negative, you add the opposite, so 7 is going to equal 7. It's a good answer. Your assignment is on the next page. This video was not actually your homework. This video was meant to just help you along if you were having trouble. So your homework starts on the next page. And the first problem, we have 2x plus 4y equals negative 18. And then we have y equals 5x plus, or, I'm sorry, 5x minus 10. So put a parenthesis around that, substitute it in for y in the first equation. Pause the video, make sure that you're setting it up correctly. Okay, you should have 2x plus 4 times the quantity 5x minus 10 equals negative 18. If you didn't set it up that way, do you see now why you would set it up that way? Now what I'd like you to do is go ahead and pause the video, try to evaluate the left side of the equation, make sure it's completely simplified, and then solve for x. Okay, When I simplify the left-hand side, when I distribute that 4 over everything that's inside, I get 2x plus 20x minus 40 equals negative 18. Combine some like terms. I've got a 2x and a 20x, so that's 22x minus 40 equals negative 18. Add 40 to both sides, so you get 22x equals 22. Divide both sides by 22, and you get x equals 1. Now take that x equals 1, substitute it in for the x here. Pause the video, see if you can solve for y. Okay, y equals negative 5. Now you can use those answers, check them in the other equation. So does 2 times 1 plus 4 times negative 5 equal negative 18? 2 times 1 is 2. A positive times a negative is going to be a negative 20 equals negative 18. 2 minus 20 is negative 18, and negative 18 equals negative 18, so it's a good answer. Number 2 is pretty much the same. Let's go ahead and put a parenthesis around 2x minus 10. You're going to substitute that in for the y right there. Go ahead and set up the equation. Pause the video, set up the equation, make sure you have it right. Okay, so we should have negative 5x minus 4 times the quantity 2x minus 10 equals 12. Again, you're going to want to simplify the left side of the equation. Do that distribution, negative 4 times 2, negative 4 times negative 10, and solve for x, and then take whatever you have for your x, plug it into the bottom equation, solve for y, and then check your work. We're not going to walk through all of the steps. We'll go over the answers tomorrow in class. Number 3 is pretty much the same as those last two, as is number 4. So 3 and 4, you have an isolated variable. So you're going to take this and you're going to substitute it in for the y there. So go ahead and do that. Number 5, I wanted to make sure that I went over number 5 with you, because number 5, neither one of the equations has a variable isolated. Neither one of them says x equals some value or y equals some value. So I want to make sure that I get one of the variables telling me what is it equal to, so I'm going to solve for one or the other of the variables. I'm going to pick the easy one. So if you have one of the variables that doesn't have a coefficient, that's the easiest one to isolate. So I'm going to pick this top expression here, or top equation. So I've got x minus 3y equals 12, and I want to get the x all by itself. So I'm going to add 3y to both sides. And some of you are thinking, but wait, don't I want the y by itself? Yeah, if I'm graphing. If I'm using substitution, it doesn't matter which one is by itself. I just need to know what x equals or what y equals. So x equals 3y plus 12. Now I'm going to take that quantity and substitute it in for the x over here. So I would set it up as 6 times the quantity, 3y, plus 12 minus 5y equals negative 6. And solve for y from there. Again, you're doing the same thing where you're distributing, combining like terms, solve for y. Once you solve for y, you take it and you plug it back in, solve for x, check your work. So that is going to conclude this video. We've gone really long, but I've not only retaught the entire lesson, but I've also given you some homework help. So please finish the rest of the problems in your packet. On the page that's at the top, it says Substitution Day 1 Homework. Solve each system by substitution. So if you need extra work to show, or extra pages to show all your work, by all means, use some extra pages, and I will see you in class tomorrow. Bye.